Welcome. Today, we're diving into the world of object detection, a core task in computer vision. Object detection is all about identifying objects within images or videos, pinpointing their locations, and classifying them into categories like cars, people, or animals. This technology powers many real-world applications, from security cameras that spot intruders to self-driving cars that recognize obstacles on the road. By the end of this video, you'll understand not only what object detection is, but also how to implement it using Ultralytics YOLOv8 in Python. Let's start by exploring why object detection is so valuable in modern technology. Object detection isn't just a technical feat, it's a practical necessity in many fields. For example, in security and surveillance, detecting people in restricted areas can prevent incidents. In industrial automation, machines identify parts on assembly lines for quality control. Autonomous vehicles rely on object detection to recognize pedestrians, cyclists, and other vehicles, ensuring safe navigation. Even in sports analytics, tracking players and balls in real time helps teams strategize better. By transforming raw images into actionable insights, object detection enables smarter, data-driven decisions across industries. Detecting objects in images or videos isn't always straightforward. Several challenges can impact accuracy. First, image acquisition conditions like lighting, shadows, and perspective can change how objects appear. Second, object characteristics matter. A chair, for instance, can have many shapes and colors, making it hard to recognize. Third, the complexity of the context plays a role. If the background is cluttered or similar to the object, the model might get confused. Overcoming these challenges is crucial for building reliable object detection systems. Let's look closer at image acquisition. The way an image is captured, its angle, lighting, and scale can dramatically affect object detection. For example, a car viewed from the front looks very different from the side or back. Strong shadows, backlighting, or reflections can obscure objects, making them hard to distinguish from the background. Additionally, if an object is too small, it might go unnoticed. If it's too large, important details can be lost. Proper image acquisition is the foundation for accurate detection. Objects themselves can be tricky to detect. Take the example of chairs. They come in all shapes, sizes, and colors. Even within the same category, objects can look vastly different. This variability makes it challenging for models to generalize and accurately identify every instance. Training data must cover as many variations as possible to help the model learn these differences. Understanding object characteristics is key to improving detection performance. The environment around an object can make detection harder. For instance, if the background has features similar to the object, the model might mistake background elements for the object itself. In some cases, objects can even blend into their surroundings, leading to missed detections or false positives. This is especially challenging in scenes with lots of overlapping or similarly colored items. Careful model training and data preparation are needed to handle complex contexts. Now, let's introduce Ultralytics YOLOv8, a high-level Python framework that makes object detection accessible and efficient. YOLO, which stands for You Only Look Once, is known for its speed and accuracy. Ultralytics wraps this technology in a user-friendly package, allowing even beginners to set up and run object detection models with just a few lines of code. Whether you're working on images or videos, Ultralytics YOLOv8 is a powerful tool for extracting valuable information from visual data. Before running object detection, you need to set up your Python environment. The requirements depend on your hardware, whether you're using a CPU or a GPU. For most users, a CPU setup is quick and lightweight. You'll need to install the Ultralytics library, PyTorch, and OpenCV. Using a virtual environment and a package manager like UV helps keep dependencies organized. Once installed, you're ready to load pre-trained models and start experimenting with object detection. With your environment ready, the next step is to load a pre-trained YOLOv8 model. Ultralytics provides several model variants, each balancing speed and accuracy differently. For quick tests or resource-limited systems, the Nano version is ideal. Loading the model is straightforward. Ultralytics handles downloading the necessary weights automatically. This means you can focus on experimenting with detection rather than managing files or configurations. To test your object detection model, you'll need some images. Ultralytics makes this easy by providing sample images you can download automatically. These images often include people or urban scenes, giving you a ready-to-use test set. The download function checks if the images already exist, so you won't end up with duplicates. With sample images in place, you're set to run your first detection experiments. Here are the sample images you'll use for testing. These images are designed to showcase the capabilities of the YOLOv8 model, featuring multiple objects and varied backgrounds. By running detection on these samples, you can immediately see how well the model identifies people, vehicles, and other objects. This hands-on approach helps you understand both the strengths and limitations of your setup. Now it's time to run inference using the model to detect objects in your images. The inference function processes each image, drawing bounding boxes around detected objects and displaying the results. You can choose to detect all classes or filter for specific ones, like person. The function also saves the output images in organized folders, making it easy to review and compare results. This step gives you immediate feedback on the model's performance. After inference, you'll see detailed results for each detected object. The output includes the class name, confidence score, and the number of objects found. For example, in a street scene, the model might detect several people, a bus, and a stop sign, each with a confidence value. This information helps you quickly assess how well the model is performing and where it might need improvement. For further analysis, it's useful to save detection results in a structured format. The Save Results function writes each detected object's data to a CSV file, including the class ID and bounding box coordinates. This makes it easy to track, visualize, or compare detections across images or models. Having results in CSV format is especially helpful for statistical analysis or integrating with other data processing tools. Let's look at the output for one of the sample images. The model detects multiple people and objects, drawing bounding boxes and saving the results. The CSV file lists each detection with its class ID and coordinates. This structured output allows you to visualize detections, track objects, and even compare results between different models or images. It's a practical way to validate and refine your object detection pipeline. Object detection with Ultralytics YOLOv8 is just the beginning. You can extend these techniques to video streams, performing real-time detection for surveillance or sports analytics. Sequential object tracking lets you follow objects across frames, analyzing their trajectories and behaviors. Advanced applications include re-identification, where the system recognizes the same object even as it leaves and re-enters the scene. You can also choose between pre-trained models for general use or train custom models for specific tasks, unlocking even greater accuracy. In summary, Ultralytics YOLOv8 makes object detection accessible, fast, and reliable. You've learned how to set up your environment, load models, download test images, run inference, and save results. With these basics, you can start building your own computer vision applications, from security systems to sports analytics. As you gain experience, explore advanced features like video detection and custom model training to unlock even more possibilities in the world of computer vision.